Hi friends, let's see another question from electric circuits and network. This question, some properties of a network theorem are given. The first point is the theorem is not concerned with type of element. The theorem is only based on two Kirchhoff's law. The reference directions of the branch voltages and currents are arbitrary except that they have to satisfy Kirchhoff's laws. Which one of the following statements has the above characteristics? So options are given like Thevenin's theorem, Norton's theorem, Tellegan's theorem, superposition theorem. Okay. So the first sentence itself, we can identify the theorem. The theorem is not concerned with type of element. So this this first sentence itself, we can understand that the answer is Tellegan's theorem. About Tellegan's theorem, I have already discussed in the question number 10. That is 10th video of this playlist. Again, I will tell you what is Tellegan's theorem. Actually, the Tellegan's theorem is applicable to any elements that means whether they are linear or non-linear, passive or active, hysteretic or non-hysteretic. Tellegan's theorem is applicable for all these elements with all these characteristics. Again, it says that the summation of instantaneous power is equal to 0. This is what Tellegan's theorem says. So the first sentence says that theorem is not concerned with type of element. That's what I already told, that it is independent of the element, which that means it can be linear or non-linear, passive or active, or hysteretic or non-hysteretic. It is not concerned with the type of element. So answer is option C, Tellegan's theorem. So let's move on to next question. A circuit is given. We have to find the Thevenin's equivalent resistance across A and B. Terminals A and B. So similar questions, a question we have already done in problem number 34. I will give the links for this problem number 10 and 34 in the description. You can see that video also. So for such questions, we can see dependent source here. 3I0 is a dependent source. How we can say it is a current dependent voltage source. Okay. In some other video also we have discussed the types of dependent sources, and this similar question we have discussed in problem number 34. And here again, let's do how to find the Thevenin's equivalent resistance. First we have to do is, when dependent sources comes in a question, for solving such question, first we have to deactivate all the independent sources. Here independent source is 5 ampere. We have to deactivate all the independent sources. Here it is a 5 ampere current source. So deactivate that current source into an open circuit, and then we have to connect a voltage source across this terminals AB, and assume a current is flowing from this voltage source. Okay, these are the 3 steps we have to do in such questions. Deactivate independent sources, connect voltage source across terminal, current I flows from this voltage source. This is how the network now becomes. Open circuited here, voltage source connected, current I is assumed here, flowing from this voltage source. Now we can identify that this I is same as this I0, right? They are flowing in the same direction. So I took I is equal to I0. Now let's apply KVL in this loop. That means plus V minus 2I. Here 2 ohm. That is minus 2I minus 3I0 minus 10I0 equal to 0. We know this I0 is I. So V is equal to 2I plus 13I, that is 15I. That means V by I is equal to 15 ohm. So this 15 ohm is the Thevenin's resistance across this terminal A and B. Let's see the options. From the options we know option D is the right answer. Hope you understood both these questions. If you have any doubt, please ask in the comment section. We'll meet with another question in another video. Till then, bye bye.